guys. So here we're gonna keep going with statistics. We've been talking a lot about the mean, the median, the mode, those central tendencies. When do we want to use the mean to describe the data set? When do we want to use the median to describe the data set? And those are all important, and all these things we need to know in order to keep going with statistics. And for this video, we're going to learn about box plots and percentiles and what they are, how we make them, what they tell us. And it's just a way to describe your data set visually. So we've been finding the mean and the median and the mode from a list of numbers. So now we're going to learn about how we can take that list of numbers and actually be able to visualize it, use a graph to show what those numbers look like with different plots. Box plots is going to be our first one. So let's first take a look at a quick example. Why does your doctor's office always check your height and your weight? Did you ever think about that? Every time you go to get a physical, the first thing they always do, they'll take you in, they check your height and they check your weight. Why do they do that? Well, the first reason is it's an indication of overall health, right? They need to make sure you're within a healthy range of your height and your weight. Second thing, for medicine dosing, they need to get your statistics on your body in order to best suit you. And the third part is so they can check your growth rate, right? Okay, so these are all things that we assume that we know. But let's take an actual look at graphs, some data of what's typical for height and weight for girls and for boys. So here is your graph of stature for age and weight for age for girls from ages 2 to 20. And it says these are the percentiles. So just take a quick look at this. Take it in, see what you notice about it. Okay, this is for females from ages 2 to 20. Kind of a lot to take in. There's a lot going on in this graph. You got your age down here, right? So as we go from left to right, you're getting older. Okay. This list of lines right here on the bottom, this is representing weight, okay? So as we get older, hopefully we gain weight. We don't want to stay the same way as we age. We're going to gain more weight as we get older. So that's the bottom piece. And then the top piece is your height. Okay, so these lines represent your height. So as we get older, we definitely get taller as well. But then it's a matter of, why are there so many different lines? Why do we care about this? Okay, so this is females, this is males, same exact thing. Notice how there are different lines with different numbers. This says 95, 90, 75, 50, 25, 10, 5. Okay, awesome. What do those numbers mean? Well, let's take a look at this slide. If you look at the lines on the chart, they have these numbers like we just said, 10, 25, 50, 75, etc. What these numbers are is they are percentiles, okay? They are percentiles that compare your data to all the other people your age. And this can be a tricky concept. What is a percentile? This sentence here hopefully will help us to explain it. It says if you are on the 75 line, so if we go back up to this graph, right, let's take a look at height. These lines are height. If I am on this 75 line right here, this line, what that means is that you are at the 75th percentile. So this 75 here means you are on the 75th percentile, which means that you are taller than 75% of the people your age. So if you are on this line, notice how all these lines are below it. That means that you are taller than 75% of the other people at your age. So for example, let's say that we have an 18-year-old. Say you're 18 right now, you're a male, and say that you were what is this? About right around 71 inches tall. Okay? So it's saying you're right around 71 inches tall, which is just about 6 feet. So if you are 18 years old and you are 6 feet tall, that means you are taller than 75% of the other boys your age. So you're pretty it's it's a rare thing, I guess you could say, right? If you're taller than 75% of the other people, that's pretty good. Not many people, not many boys age 18 are 6 feet tall. Okay? So that is a very tricky concept to wrap your head around. It's abstract and it can be very confusing. So you just got to be careful. You got to really take a step back and understand what it is that percentiles are. So let's take a look at this slide here. So here on the left side, it's showing the percentiles for females for height, and on the right side, it's showing the percentiles for males for height. We have this first question here. Who typically reaches their adult height faster? Now, let's just say, for convenience sake, adult height is age 20, okay? Well, let's just say this is your adult height, age 20. If you look at this graph, these two graphs, compare them, do females or do males reach their adult height first? What do you think? Well, taking a look, if I look over on this left piece, it looks like females, they're growing until about age what, 15 or 16? Right around here is when they start to level off, right? They're not getting any taller. So right around age 15, I would say, is when girls start to reach their adult height first. Now, if we look over on this side, looks like males, we're still getting taller. They start to level off at about age 19, right? Going up, and then it starts to level off right about here, age 19. So who reaches their adult height first? Well, females, girls. They reach at age 15 compared to males who reached at age 19. But then the second question is, who is typically taller? Which gender is typically taller? Well, if I want to look all the way to the end, age 20, right? That means that 97%, the 97 percentile is about 69 inches. So females, the tallest female is typically about 69 inches. Compared to the male, when they're age 20, the 95th percentile, their highest height is about 74 inches. So from reading this data, we can tell that who is typically taller? Well, the males are typically taller, okay? And that's not just from 97 percentile. We can look at all these percentiles, okay? It's shown that these lines are higher than the females' lines, okay? So something to think about. Now, let's actually we got a nice concept of what a percentile is. So let's go on to what a box plot is. And again, you need to understand the percentiles in order to really get how a box and whisker plot works. So this is what the general view of a box and whisker plot looks like. This is a very nice layout. Here's your box right in the middle. And then these lines here represent your whiskers, as we call them. What's important to note is how each different line, there's a different color. See, we have one line, two lines, three lines, four lines, and then your fifth line. Each of these lines are super important. And it says this is your minimum, This blue line is your lower quartile, or known as quartile 1. This red line is your median, which we know what that is. This orange line is your upper quartile, or quartile 3. And then this last line is the max, the maximum, the highest value in your data set. Okay? And then this piece here, interquartile range, well, all that is, we'll learn more about that as well. That's what we get when we take our upper quartile, Q3, and subtract the lower quartile, Q1. And that gives us this middle piece. Okay. So here, again, now it's in a nice table format. Let's just say I have, I'll make up some numbers. Your minimum, let's say 21. Q1 is 27. Your median is 32.5. Q3 is 36, and your max is 42, right? I just made these numbers up. So, important to note, minimum is definitely your lowest value, maximum is your highest, median is right in the middle, and then you have these things over here, your IQR, which again we said was Q3 minus Q1. So if I want to find the IQR for this piece, my Q3 is 36, minus my Q1, which is 27. So that is an IQR of 9. But then on the other hand, the range, I think you should know this from 8th grade, the range is your highest value minus your lowest value. Your max minus your min. So we take our max, 42, minus 21, and we actually get 21. That is the range. Okay, so important information there. Super important information. Box and whisker plots. Each section accounts for 25% of the data. Very important to understand. Each section accounts for 25% of the data. So notice here, from the min to the lower quartile, that's 25%. From the lower quartile, Q1, all the way to the median, which is Q2, that's another 25%. Median is also known as Q2. And then from the median to the upper quartile, Q3, that is another 25% of the data. And then from Q3 to the max is another 25% of the data. Okay? Quartiles. Notice how it looks a lot like the word quarter, right? Quartile looks like quarter. Always remember that, because a quarter we know is worth 25 cents. Right? That might be backwards, I don't know. But a quarter is worth 25 cents. So it breaks it up into quarters for box plots. Let's take a look at an actual example. Find each value and construct a box and whisker plot. Okay. Can we do this by hand? Sure. Should we? If you want, is an easier way. What I would do is what we learned at the end of last video. You're going to want to use the calculator. So everybody should have out their calculator. Step 1. You're going to want to hit stat. Right? So where's my calculator? Here it is. You're going to want to hit stat. Okay, awesome. Step 2. You're going to want to hit edit. So, stat, edit, and then L1. You should be in L1. This is where you want to enter all of your data. Okay, so you want to enter your data or your numbers into L1. So what are the numbers that we have here? 10, 12, 13, 15. So everybody should do this now. 10, 12, 13, 15, 20, 25, 27, 30, and 33. Check, make sure all your numbers are there. 10, 12, 13, 15, 20, 25, 27, 30, 33. Okay, awesome. So once those numbers are entered into your data set, step 4, you got to hit stat again. If I'm going too fast, pause the video. You got to hit stat again. Step 5, you got to go over to calc. Oops, calc. So we hit the over button. And step 6, hit one var stats. First one we see. Enter, 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 calculate. And again, it brings up this nifty list of numbers. Okay. What we care about right now are these last 5 numbers. Min, Q1, med, which stands for median, Q3, and max. These are the 5 numbers that are crucial that we need in order to construct a box and whisker plot. So fill in what we got. The min is 10. So go back up. The min we said is 10. Q1 is 12.5. The median is 20. Q3 is 28.5. And the max is 33. Okay? Now that we have these 5 things, which we always need for a box and whisker plot, we can now make our box and whisker plot. First thing we got to do is create our number line. Remember, for number lines, they need to be consistent. I can't just put 5 little lines here, right? Like, this is my min, here's my Q1, here's my median, here's my Q3, and here's my max. No, I can't do that, okay? Just like when we graph, it needs to be consistent. I gotta have a consistent number line. So what is going to fit between 10 and 33? Well, let's go up by 5s, right? So let's say 5, 10, 15, 20, and actually these are not spread out enough. I just noticed that quick, so try this again. 5, 10, 15, 20, 25, 30, 35, 40, and this is good. 5, 10, make sure you label your number line. 15, 20, okay? So there's our number line. Next thing we gotta do is make our box and whisker plot. So what I'm gonna do is get rid of this here. We know that's our number line. The min, first thing we wanna do is the minimum. Well, the min is at 10. So that minimum is going to be my first vertical line, right? So there's 10. Q1 is at 12.5. Again, Q1 is the start of your box, okay? So that means that I'm going to go to about 12.5. Let's say that's about right here. And that is going to be the start of my box. Okay, so there's my first big line for the start of my box. The median is 20. That is the middle of your box, right? So I'm going to put a nice big vertical line here. Here's the middle of my box. And then Q3 is going to be the end of my box at about 28.5. We'll say that's about right here. And now I can connect my lines to make my nice box here. Right? And then again, the max is 33. That is the end of my whisker. That should be right about here. Okay? That's kind of a thick line, but that's okay. Right about there. And that's my box and whisker plot. It might not look pretty because it's kind of hard to write on this, but notice how my min is 10. Here's my Q1. Here's my median. Here's my Q3. And here's my max. And again, remember, between each piece, between min and Q1, that's 25% of the data. So here's 25% of the data. From Q1 to the median, that's 25% of the data. Between the median and Q3, that's 25% of the data. And then between Q3 and max, that's 25% of the data. Broken up into quarters. Get everything you need for this. Go on to the next page. So here's something I want you guys to try, okay? I want you guys to take a look at two different box and whisker plots, okay? So this represents boys, this represents girls, and it looks like they are comparing their heights. So go ahead and try this. Pause the video, see if you can do this on your own. Okay. So which are true and why? Number one, the girls are taller on average. Well, again, what does that word average mean? I actually just said it. Average is your mean, right? It's the average of all the numbers. A box and whisker plot does not tell us the average. It doesn't tell us the mean. It tells us the median, though, right? This middle line is our median. So let's use that. The girls are taller on average. No, it doesn't look like it. It looks like the boys, their box here is farther along to the right, higher. So the girls on average are taller. No, that's false. The boys are taller on average. Yeah, that's true. They're a little bit more to the right. The girls show less spread in height. Less spread in height. What do you think that means? Well, think about it. Which one is spread out further, girls or boys? It's really saying which one has the higher range, max minus min. Well, just eyeballing it, I could see that the boys have higher spread. So the girls show less spread in height? True. Yeah, it's not as spread out as the boys. The boys show less spread in height? No, they show more spread. The shortest person is a girl? Yeah, yep, minimum, yep. The tallest person is a boy. Is the max a boy? Sure is, that's true. Now it says both data sets are skewed to the left. Skewed. Let's take a look at this slide. To figure out skew, look for which side has a longer tail. Okay, so if I have a box and whisker plot, this green one, where it has this tiny tail and then this really long tail, this means it's skewed to the right for this green piece, skewed right. If it's skewed left, the tail is going to be going left. It's longer on the left side. So the tallest person is a boy. Oh, we got that. Both data sets are skewed left. So again, is my tail longer on the left for both sides? Definitely is. These are both skewed left. That's true. Number 8, half the boys are over 172 centimeters tall. Okay, remember, between each piece is 25%. So from here all the way down, this from here to here, this is 25%. From here to here, this is 25%. So yeah, half the boys are over 172 meters tall. That's definitely true. And I think that video is long enough, guys. Make sure you get the notes. Make sure you send them. And I hope you